Today, I'm thrilled to be joined by Tony Fischels, Vice President of Power One, which is a division of Airsys. Thank you for joining us, Tony, and I hope I got your name right.
You did, and thank you, Jordan. Glad to be here.
Excellent, thank you. I want to jump right in. Can you tell me more about the Power One division within Airsys and how your solutions are built to handle the ever-increasing power densities in AI data centers?
Yeah, of course. So Power One is a newer division within Airsys. It was really created to tackle some of the challenges we're seeing today in the AI data center deployments. Some of those challenges are around, infrastructure densification, stranded power, quick deployment, et cetera. So Power One is made up of two single-phase liquid cooling solution sets. One is direct to chip, which is more or less standard products you'd see at most data center deployments today. And we have a very revolutionary new technology called liquid rack, which is a spray cooling technology that sprays directly where the coolant sprays directly on the chip rather than going through a cold plate. We've really created a completely new category in the industry, which we're calling server level cooling or server level liquid cooling unit.
I think recently we did a trend report which discussed a bit about spray cooling, but I want to ask you now, what would you say are some of the advantages of liquid rack, and how do you see this solution fitting into current or future data centers?
Yeah, so for liquid rack, it has advantages at both the server and chip level and in terms of infrastructure too. So at the chip level, with the spray cooling technology, we have the ability to reject more heat at the chip compared to, let's say, a standard direct to chip solution where we're going through a cold plate. At the infrastructure level, it really simplifies the system overall, the cooling system. We bring those heat exchangers and pumps that you typically see in a CDU to the rack level, and we also operate as a compressorless system. So we really have a dry cooler connected to liquid rack and nothing in between. We see this as a really good fit for legacy type data centers where there isn't a lot of room to maybe move from air cooling to liquid cooling. And then as well as some of these larger data centers too that are just looking to reduce the amount of infrastructure they're using for their cooling infrastructure.
I think this has been a major concern when it comes to AI data centers. Everyone wants to be as dense as possible, and obviously cooling and power, and it all takes up excess room that I'm sure we'd rather have servers in there rather than all the ancillary equipment that we need. And I really like that point there. Legacy data centers, they weren't built for the AI era, and yet obviously we don't want to leave them behind. So it's a really good point that you make there. Now, something that I read, and for a long time, power usage effectiveness has been the main benchmark used by data centers, but Airsys has been promoting power compute effectiveness as a new metric. Can you explain how this differs from PUE?
Yeah, absolutely. So our compute effectiveness does work hand in hand with PUE. It's not that we're trying to shove PUE aside. PUE has been used for a long time in the industry, and it essentially is a metric for cooling efficiency for the most part. PCE is more focused on compute, and really what it is, it's the ratio of power allocated for compute compared to that of the facility overall. It's a metric that falls more in line with how data centers are designed and built today and shows how much revenue is being generated from provision power as well. So we feel that the way that we see data centers being built, that PCE falls a little more in line with it.
There's no such thing as, in my opinion, no such thing as too much data.
Right.
If you have a full view of what's going on there, you can optimize a lot more. Now, with 2026 coming up, we've been getting a lot of predictions. Naturally, AI isn't going anywhere. Hopefully. So I'm wondering if you can share what you think some of the challenges that customers should consider when preparing for the future of AI builds, and exactly how can Airsys be of support there?
Yeah, absolutely. And I'll talk in terms of cooling systems here, but one of the bigger challenges is really designing for a data center today knowing that, let's say, your cooling system will have to adapt to the increasing workload densities of the future. At Airsys, we do believe we have the technologies to create what we call a thermal evolution path, essentially a path to, swap in one technology for another with that system that is designed today, going from direct to chip to server level liquid cooling, and then moving on to potentially two-phase solutions using the same system. We have a partner company that we call Aegis, which is our partner arm that has created two-phase solutions, so we can tap into that as well.
Excellent. And I think, that bit of future proofing is going to be so crucial, because I think as quickly as NVIDIA can pump out new chips or other chip makers, they are pumping out more and more, and racks are getting denser and denser. So we need to solve the cooling challenge, because the two big challenges right now in data centers is power and cooling. And, if we don't think of the future, then we're just going to be here all over again in just a few years' time. Right. Thank you, Tony. That is all my questions. Thank you for giving us your time today. And I just want to once again thank Airsys for sponsoring this video.
Thank you so much, Jordan. Really appreciate it.